The good thing about working with polynomials and derivatives is that we can treat each part of the polynomial as its own little question. So when we're required to find the derivative of this one, we actually will be finding the derivative of 4x cubed. It's going to go down there, and then we're going to find the derivative of x squared, and it's going to go in there. Whatever sign we had up here, plus, it goes in between. Now to do this, we need to really remember that we're going to have a 4 and an x, and we're going to be bringing the old power right down the front. 3 times 4 will be out front, and we subtract 1 from the old power, 3 minus 1. So in here for the x squared, we'll be bringing the 2 down the front, x, and we take 1 off the power. So having done that moving, we then rearrange everything and get ourselves 12x squared plus 2x to the 1. Simplifying that, finally, we get a result like that. So what have we done? Most critical step involves placing the 3 at the front of this particular term and subtracting 1 from the power. We do the same on the second of the terms. We brought the 2 down the front and we take 1 off the power. Then the rest of these questions really is about how we arrange our algebraic expressions to get a result that looks as much as we can like a polynomial. That is, we aim for positive indices, try and get rid of any fractions and simplify it down in terms of like terms throughout. In this second example, we're going to try and find the derivative again, dy dx, but we need to look at the way that the question is presented. Now, surds involve a square root sign. That's what we're traditionally used to them as. In this case, it's a square root. If I had a 3 up the top of the x, then it would be a cubed root, etc., etc. In this case, a relatively straightforward one. We're talking about the square root of x. Now, over here on the side, I'm just going to focus on our understanding of what's going on with these surds. The square root of x, it's a memory thing, is the value of x raised to the power of a half. And that's how we can convert between surds and index form notation. Can extend it a little. You can have the third root, in which case it's x to the power of a third. You can have any value outside, and in that case it would be x to the power of 1 on n, where n was the number outside the surd sign. So having accepted that we've got this group of possible operations for surds, we can proceed now to recognize that this can be re-expressed as y equals x to the power of a half. To find its derivative, we have the x to the power of a half, bring the half down the front because it was the old power, and subtract 1 from it. So what we've done is we've taken the old power, put it down the front, and we've subtracted 1 from the old power. So the same power rule applies to surds, just need to get them in index form so you can work with them appropriately. To finish the question off then, we're still going to have a half x to the power of negative a half. Now in this case here, a couple of things to remember. Anything that is to the power of a half, negative a half, sorry, is in fact the same as 1 over x to that power. So in this case here we have 1 over two fractions, multiplying fractions 2 by x to the power of a half, and that can be simplified then back into surd form if you wish. Probably a good way to go, and we get an answer like that. Again, critical steps with a question like this are to recognise the conversion from surd form to index form, and then to process it exactly as we would under normal circumstances, and to carry out the simplification, giving ourselves an answer that would typically be written more often than not in surd form, but certainly with positive indices at the same time. The third example works on the basis that the expression for y can be rewritten from surd form into index form, and we would then proceed to find the derivative based on the idea that we're going to bring the old power down the front and take 1 off the old power. So we'll end up with 1/3 out the front multiplied by x to the power of 1/3 minus 1. So again, the old power goes down the front and we subtract 1. We'd end up with 1/3 times x to the power of negative 2/3. That is to say, 1/3 minus 1 equals negative 2/3. To complete the task, we'll simplify things down, then try and work with our fractions. Now this is going to be 1 on x to the power of 2/3, rewritten in such a way so that we can combine these two together as a fraction with a common denominator. 1 over 3x to the 2/3, which could be ultimately represented as, and now using our index clause, it's going to be the x squared to the cubed root, and that's the final answer. The final example for this set involves we'll call it a complex surd. It's going to be x to the power of 4 over 3. That is to say, the 4 that's inside the surd is x to the power of 4, and the 4 on the numerator of this fraction reminds us that it's 4 wholes, x to the power of 4. Having done that, to find the derivative, we do as we have done previously. We get ourselves our old power and we're going to bring it down the front, and we're going to take 1 off. So we will get 4/3 of x to the power of 4/3 minus 1. In this case, it'll be 4/3 of x to the power of 1/3. That is 4/3 minus 1, or 3/3, is 1/3. To complete the question, it'll be 4/3 of x to the power of 1/3. Everything that is on the numerator, which is a 4x to the power of 1/3 over 3, or 4x cubic rooted, it's cubic root of x over 3.